Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is arithmetic operations on functions. Functions behave exactly as one would expect with regard to the four basic operations of algebra: addition, subtraction, multiplication, and division. When functions are combined by these operations, though, the domain of the new combined function is only the elements that were shared by the domains of the original functions. So here are the formulas for combining functions: addition, subtraction, multiplication, and division. Yes, functions can be added, functions can be subtracted, functions can be multiplied, and functions can be divided. Here is the rule for addition of functions. F of g of x is nothing but f of x plus g of x. And the formula for subtraction is very similar to addition, only the sign is different. And for multiplication, f of g of x is nothing but f of x dot g of x. Dot here means multiplication. And for division, we can just divide the functions. And there is one more way that functions can be combined. The fifth operation is called composition of two functions. We can discuss about that topic in a separate video. The composition of functions, you can consider two functions, f of x and g of x, is symbolized in this way. F dot g, this dot is different from the product. It is equivalent to f of g of x. The concept is simple. Now we can concentrate on the algebraic operations. We are used to adding, subtracting, multiplying, and dividing real numbers. We do these operations every day in a variety of situations. We have also learned how to perform these four basic operations on algebraic expressions also. So, while we may not need to calculate, for example, 30x square over 10x, we need not calculate this too often. We don't know how to do it. So if we know how to perform the four basic operations on polynomial, then we can also add, subtract, multiply, and divide the functions. The notation will look different at first, but we can understand this concept just by doing a couple of steps. Okay, so let's first look for the notation we are using. A function is a correspondence between two sets, the domain and the range. In addition to evaluating functions, you can do operations with functions. So let's say you're working with the following two functions, f of x and g of x. Let f of x be 9x minus 5, g of x be 4x minus 1. The sum of these functions can be written as f of x plus g of x, or you can also write this as f plus g of x. Okay, let's watch what happens when these two functions are added. This is nothing but adding these two expressions. 9x minus 5 plus 4x minus 1. First distribute the sign. Since there is a plus sign in between, there will be no change in the terms in the second parenthesis, even after combining. Now let's add the like terms. 9x plus 4x, that would give you 13x minus 5 and minus 1. That's it for this example. The sum of the two functions is nothing but sum of the two polynomials. Addition, subtraction, multiplication, and division will be explained in turn. So let's start with adding and subtracting two functions. So this is how we use the notation. Just add two functions. We have already seen one example of adding two functions. Let's look at another one. The domain, I mean the x values. Domains are the inputs, no? Inputs means x values. For both the functions is all real numbers. Here are two functions, f of x and g of x. Let's find f plus g of x. F plus g of x is nothing but f of x plus g of x. So in the question you have to identify what is f of x and g of x, and then replace f of x with 5x plus 6 and replace g of x with 3x square minus 4x plus 8. Since we have plus sign in between, even if we distribute the sign, there will be no change in the signs of each term inside the second parenthesis. So we have to combine the like terms. Let's start with x squared term. We have only one x squared term, so 3x square. Look at the x terms. We have two x terms, 5x minus 4x. So 5 minus 4 is 1. So 1x and x both are same. Now combine the constants. 6 plus 8 would be 14. That's it for this example. And if you are concentrating on subtraction, subtracting follows the same process. As long as you remember how to subtract one polynomial from another, you can easily figure out how to subtract one function from the other. So let me show how to do subtraction for this expression. Let's use the same example. So formula for this is going to be f minus g of x, that is f of x minus g of x. You have to identify what is f of x and g of x in the given question. After that, replace f of x by 5x plus 6 and replace g of x by this expression. After replacing g of x and f of x with their respective expressions, you have to distribute this sign. Negative times positive would give you negative, negative times negative will give you positive, negative times positive is negative. Now you have to combine the like terms. Same as the previous example. You always start with the term with highest exponent. So here x square. That's it for this example. You can also try g minus f of x for the same example and post me the answer, whatever answer you're getting in the comment section. Okay, let's move on to the next example. I'm going to post an example for subtraction again. Here is the next example. Three functions are given: f of x, g of x and h of x. And in this question we are supposed to find f minus h of x. Please notice that f minus h of x is nothing but f of x minus h of x. So you can ignore g of x since it is not required to solve this problem. So you have to identify what is f of x and what is h of x in this question. F of x is t, 5x square plus 2x minus 5 and h of x is 4x square minus 10. Just replace these function notations with appropriate polynomials and then we are going to subtract. We have replaced f of x by 5x square plus 2x minus 5 and replaced h of x by 4x square minus 10. Please notice that we have a minus sign in between. So you have to distribute this minus sign. So we will get, you have to be clear with rules of signs for proceeding with all these operations. Okay, after distributing the sign, you have to combine the like terms. So start with x squared terms. 5 minus 4 is 1. So 5x square minus 4x square is x square. And we have only one x term. No other term to combine with it. Now combining the like terms we will get, so here is the answer, x square plus 2x plus 5. You may also get some word problems, but mostly you'll be getting polynomials only directly. Even if you get word problems, identify the functions and plug in the respective functions with the suitable operations. Now let's move on to multiplying and dividing functions. Multiplying and dividing functions is also just like multiplying and dividing polynomials. So here is an example for product. Please consider this example. F of x is 2x plus 1. G of x is 5x minus 3. Let's find the product of the functions f and g. F times g of x is nothing but f of x times g of x. To find the product, we are just going to multiply the given functions f of x and g of x. Replace f of x with 2x plus 1 and g of x with 5x minus 3. Since we just have two terms in each of the functions, this will look like FOIL method. First multiply 2x with each and every term in the second parenthesis. Same way multiply positive 1 with the terms in the second parenthesis. So let's start with 2x. 2x times 5x will give you 10x square. 2x times minus 3 will give you negative 6x. Same way multiplying 1 with 5x will give you positive 5x. Positive 1 times negative 3 will give you negative 3. Now it's time to combine the like terms. We have only one x square and one constant. We have two x terms. So combine these two terms. So the final answer is going to be, hope you're clear with this example. Okay. Now let us move on to an example for dividing. Here is an example. We have two functions, f of x and g of x. F of x is 12x cubed plus 15x squared minus 6x and g of x is 3x. We have to find f over g of x, which is nothing but f of x over g of x. To find the quotient divided by g, f divided by g, substitute the polynomials in for f of x and g of x, and then we have to divide. Here x is not equal to 0, because if x is equal to 0, the denominator g of x would become 0 and the fraction will become undefined. So you have to set x is not equal to 0 here. Okay, now let's divide these. You can take a common factor outside in the numerator. 3x is common factor in the numerator, so take that out and write the leftovers in a parenthesis. You can cancel out this factor and we will be left over with. So these operations will be no different than what you have already done with the polynomials. So just substitute the polynomials in for the correct functions, combine, divide and simplify. That's it. Hope you got an idea on arithmetic operations on functions. In case if you have any query regarding these topics,